Okay, so today we're going to go over the limit definition for calculus. This definition is used to find the derivative of a function. The first derivative is used to find the slope at any point on your graph, so a point x comma y. It is also going to provide you with the slope of the tangent line to a function, which I'm going to go over tangent line and secant line in another video. But this slope that you find is called your instantaneous rate of change. So do not confuse that with your average rate of change. For the limit definition of the derivative, this is the formula for it. So it's the limit as h approaches 0 of f of x plus h, which is right here, minus f of x all over h. So what is f of x plus h? Anyways, well, f of x plus h, let's think about it. F of x is just a y value, right? Any y value when you plug in an x value. So if I plug in a 2 for x, it will give me whatever y I have on my graph when I go to 2 on x. So f of x plus h is just another point for an x value. So it's just standing in place of another x value on your graph. So all you have to do is plug in x plus h in place of x. Let's do an example. Let's say f of x is x squared. Well, what I always tell my students to do first is find f of x plus h before you plug it into your equation. Because sometimes you're going to have to do some work and simplify it, and simplifying it within the equation can get a little confusing. So f of x plus h goes in the parentheses in place of x. So x was squared, so this took the place of x, and it will be squared. Well, as you can see here, this can be simplified. But how? Well, this is the same thing as x plus h times x plus h, because that's all it means to be squared. Something times itself. So all we're going to have to do here is use the FOIL method. FOIL. So first, outside, inside, last. So my first terms, I'll move to a different color. My first terms are going to be x and x. So that'll be x times x is x squared, because we have 2 of them. Outside for O will be x times h. So plus xh. I means inside, so h times x again. And then last, h times h, which is h squared. Okay, so now we have f of x plus h. And this is what we're going to be plugging into the function, which we can simplify one more time and get x squared plus, we have 2 xh's. So we have 2xh plus that last term h squared. Okay. Now that we're done foiling and simplifying that function, let's put it into the limit definition. Remember, our original function f of x was x squared. So I'm going to put it right here. So my limit definition says, as h approaches 0, f of x plus h minus f of x all over h. So if I plug in everything, I get f of x plus h, this equation, minus, always put this in parentheses because sometimes it's going to be x squared plus 2 or multiple terms. When you have multiple terms, this negative is going to affect all of those terms within it. You'll be subtracting every single term, not just the first term. This case, it'll be minus x squared. That's just one term, so he's only going to carry one negative. And then don't forget to put this all over h. A quick comment. When you're finding the limit, if we go ahead and do direct substitution here, what will happen? Well, you'll be putting a 0 into the denominator. The denominator is the bottom of your fraction. You can't have a 0 under the denominator. That is undefined. So we cannot directly substitute, and we're going to have to simplify first. So let's go ahead and get that work done. F of x always cancels here. Sometimes you have to do quite a bit more simplification first, but it will always cancel. So we have x squared was our function. Well, it canceled. So now we're left with the limit as h approaches 0, 2xh plus h squared, all over h. Notice now, all terms have an h, which is good because we need to divide out an h. We need to get rid of the denominator h. So now we take the limit as h approaches 0 and factor out that h from all the terms inside. So if we put the parentheses and we factor it out, if you take one h out of this first term here, you're going to be left with 2x. If you take an h out of the second term, instead of being h squared, it will also become h. Simplify. Now we can cancel. Anything divided by itself is equal to 1. H over h is just the same thing as 1. So those cancel. Now our terms are much more simple, and we're left with 2x plus h. Well, now since we don't have h on the denominator, we can plug it in and do direct substitution. Once you directly substitute in your value from your limit, the limit goes away. 2x plus 0 simplifies to just 2x. And this is your f prime of x, or what you would also call your first derivative. So now that we have this function, what can we do with it? Well, the first derivative gives us our slope. So if I plug in values for x, so let's say we plug in 2. 2 times 2 is 4. That means I have a slope of up 4 on my y to the right 1 on my x, because it's rise over run. I'm going to do a couple more complicated ones on another video. So this will be concluding the first one. This is our limit definition for the first derivative.